couple of things that we've talked about so far, we already know. Excuse me. Hey, we some coffee here. Yeah. We're all gonna die. Isn't that just hysterical? They did. There was an episode where they had ordered something from China, and one of the workers was boxing the thing up, and he was sick. And you see, when you see cartoon characters cough, you see like the green fuzz come out. He coughed into a box, and then they opened up the box, and they all got sick. I don't think it said that. But it was from Hulan or whatever. It was from the part of China. But anyway, circles. Shh. We talked about 2 out of these 5 things yesterday. We talked about the radius and we talked about the diameter. Just to reiterate, the radius, if you recall, was the section, or the segment, from the center to the side. So it's the segment from the center to the side. This is something you guys all know. This is nothing anything new. We also know that all the radii within a circle are always the same. They're all congruent. Okay. Again, this is stuff that you guys learned a long time ago. This hasn't changed. The other thing that we talked about yesterday that I know that each and every single one of you worked with at some point in time was also the diameter. And if you recall, the diameter is just a segment that goes from side to side, but it passes through which point? The diameter is made up of 2 radii, and a lot of times you just kind of quickly draw it straight through, and that would be your diameter. So that's the segment from side to side. Oops. More importantly, it goes through the center. Okay? When you have a diameter, can any other segment in a circle be longer than a diameter? No. No. Why? Could I draw another segment that goes from side to side, though?
Oh, yeah, you're right.
I'm sorry, what's that? Can any other segment in a circle, if I drew another segment, that goes from side to side, can it be longer than the diameter?
No.
Why?
The radius is the center to the end. As far as it can go. So
Okay.
the diameter is double that.
Okay. Okay, so I'm waiting for somebody to see the line. Because what does the diameter do to a circle? It cuts it in half. Anything less than that doesn't cut it in half. Okay? So what a diameter technically is what's called a chord. A chord, this isn't working. Prove me wrong. Prove me wrong. Is a segment from side to side. So technically a diameter is a chord, but it's the most specific one. A chord can still just be this, edge to edge. That's why a diameter is more specific. A diameter is a very specific chord. Okay? The diameter goes edge to edge, just like the segment goes edge to edge, but the chord is fancier. Question, Nolan? Question? Okay, then keep it up, please. Thank you. All right. So chords can go all throughout the circles. Okay, some are longer than others. None of them will, all chords will be smaller than a diameter unless it is in fact the diameter. And how that works like that. Okay. The secant. The secant is a line that goes through a circle. Think of it this way. It just goes through it. It touches the circle at 2 spots. It doesn't necessarily have to go through the center. Okay? It just goes through a circle and it touches it at 2 spots. We do things with secants later on when we start talking about specific segments that occur within circles. We also deal with more stuff with chords as well. I think we do the chords. Is it Friday, I think? Friday or Monday? I don't remember. I think we stick with the angles. I don't remember. Anyway, so we have secants. Think of it this way. A secant is like an arrow going through an apple. And if you put an arrow through an apple, it destroys the apple. Or if you think of a circle being your head, if an arrow went through your head, it would destroy your head. So think of the song, secant, destroy. See what I'm doing there? Secants go through, and they destroy.
No, that's a lot.
That's a lot, yeah, no. Stop it. Anyway. And lastly, tangent. Tangent is not the tangent that you think of in terms of SOHCAHTOA. Tangent is kind of like what I do when I'm talking to you every once in a while. We go off on a tangent. I go off on tangents. You know where that came from? That's where this comes from. A tangent is a segment, let me move this up a little bit here, is a segment, a line, a ray, it could be anything really. Do segments go on forever? Ooh, counterexample. Yeah.
For a ray, that goes on.
Which direction though? Does it go but does it have it can stop somewhere though.
I mean, we don't know that.
It has an endpoint. Anyway, that touches the circle at exactly one spot. And it's perpendicular to a radius. Okay. There's a lot of writing there. So the idea of what a tangent does, a tangent can be a segment, a line, a ray. It can be anything that touches the circle at exactly one spot. If you touch a circle at exactly one spot, you can always draw a radius to that spot that's perpendicular. It does not matter. If you think about circle?
Circle.
Sure. Second. Now, that segment is touching it as exactly. Nice. This is why we don't have nice things. And if I rotate this thing anywhere around the circle, it's still touching it at technically at one spot as it goes through. Okay. So where the saying goes through off on a tangent, when a radius touches it, turns a right, creates a right angle. The idea is you're going along one way and you just make a right turn. You go off on a tangent. You change direction. That's where this term came, that's where the saying comes from. Oh, there goes Murphy. He's off on a tangent again.
Right.
It could be a left turn, but if I turn right 3 times, I'm going to turn left. But did I turn left?
No, if you turn
Are you sure? Stand up. Yeah. It's not like it's hard to stand up. You're not that old. Don't complain about your knees yet. You're not old enough. Hang a right 90 degrees. Hang another right 90 degrees. Hang one more right 90 degrees. What way are you facing from your original way? But you're facing left. Did you make a left? But now you turned left. Nobody likes you, Harlan. Is he right or is he wrong? Or correct? Is he left? He's on your left. Unless you're facing the other way, then he's on your right. But is he technically on his right? Can he also be on your right? Yeah. Just a really long way away. Yeah, hence tangents. Okay. Shut up. Nobody likes humor anymore. So, anyway. Sorry. Tangents, when you talk about a tangent, it's just a segment that touches the circle at one spot. It's always perpendicular to radius. What will happen with a lot of these things, you'll start to see right angles. You see right angles, that means you're going to see right triangles. You see right triangles, you're going to start seeing you can see special right triangles, you can see Pythagorean theorem. All those bits and pieces come back into play. Okay? For example, we did all those, did this. What'll happen, if you remember some of the instructions on that CUDA sheet from yesterday, where it said segments that appear to be diameters, in fact, are. You guys remember reading that? You'll also start to see things that will say segments that appear to be tangent are. Okay? So what that allows you to do is it allows you to look at diagrams and do some implying or some inferences of what you actually see. For example, here. As you look at this circle, this was technically circle O. Everybody okay with that? Because the center is labeled at point O. Now, it also shows that you've got a segment from the center to side as OD would be, it looks like it's a radius. There's no point below it, but doesn't that appear to be a diameter? Okay. So there's your diameter. Now, if you look at segment DE, does it appear as though it's touching the circle at one spot? Yeah. When it looks as if it is, it is. It's kind of a weird way of saying it. So that means then, what angle is here at D? 90. How many degrees are in a triangle? 180. Correct. So you just back things out, back out your 90, back out the 38. Or if you remember, as soon as you have a 90-degree angle here, the other two angles are always complementary, which means they have to add up to 90. It's another way of doing it. There's a bunch of ways of going about it. So simple, quick math, you get 52. Okay? Again, this is the end of the world for you if you get the degree symbol.
Yeah, no. Maybe.
Like I said, I'm going to forget 8.5% of the 8.5 times anyway. So. I don't even know what I'm talking about half the time. Just nod and smile and humor me. You feel bad for my wife? Yeah. Feel bad for my children. Anyway, what does it look like we have now? We have a triangle, don't we? What kind of triangle is it? It's a big triangle, idiot. A big triangle is just a triangle. It's a right triangle. Okay? So, what is it asking you to solve for? Is it asking you to solve for an angle, or is it solving for a side? How many sides of said triangle do you know? 2. If you know, do what? It's okay. You're on the right track. You use the a squared, b squared, c squared stuff. Now, what happens here is you look at the information that you're given. In this case, you have 2 out of the 3 sides. As soon as you see that you have 2 out of the 3 sides in a given triangle, if it's a right triangle, you're obviously have to use Pythagorean theorem. So, in this case here, the 96 is the tangent segment, because you notice how it's touching the circle at one spot. It's right angle. The value of x is excuse me, we're trying to find the radius in this case. So, which of these 3 segments is playing the role of the hypotenuse? 100. So, you put it together, you got your x squared, 96 squared equals 100 squared. This is something that we've done a bunch of. Subtract the 96 squared, type it in your calculator. What is 748? Does that sound right? 784. Thank you. So when you type all that through, you wind up with 784 equals x squared. I wonder what you have to do to solve for x. You're wrong. You don't multiply by 2. You have to take the square root. I think this was a perfect square, wasn't it? Was it 28 or 18? 28? So get your value of x at 28. Okay? Not too terrible. Once again, you're bringing back together some stuff that we've all done. I know we've done Pythagorean theorem at least since probably the 3rd or 4th day of the school year. You remember it was remember how we called the distance formula without forever calling it the distance formula? So this isn't anything new. What becomes new though is this version of it. And I know that a lot of times in here we get going on something really easy, and then all of a sudden, wham! And I sneak up on you and you guys go, ah, you scared the angle side out of me.
That's fun.
I didn't want to say something else. But anyway, same principle here. Okay? Same principle. We're trying to figure out what the radius is. Okay? I don't know what it is. Now, when you look at it, let's think of it in terms of our letters. What segment via the letters is the hypotenuse in this picture? AC. AC is our segment of a hypotenuse because it's across from the right angle. Are we okay with that?
Yes.
All right. So what I'm going to do here is just kind of highlight it real quick so we can see what we're looking at. We're looking at this whole segment here. Well, if this segment is made up from x from here to here and 8 from here to here, what's the whole thing? X plus 8. Notice, all we're doing here is we're adding 2 segments together. Boy, have we done that once or twice before as well.
I don't recall.
You did arc addition yesterday with angle addition. Now it's back to segments. This whole piece is x plus 8. Now you just told me that the Pythagorean theorem, it's going to be something x squared plus 12 squared, and it has to equal whatever CA was squared, right? Well, CA is what segment? It is x plus, not 8x, x plus 8. So when you have a binomial, we have 2 terms with a plus sign or something between it, you have to throw it in parentheses and write x plus 8. Here's where you guys are going to screw up. Badly. Okay? That stands for x plus 8 says quantity squared, which means you have to multiply it out twice. Okay? The way I've always taught that setup is this. Junk squared. The junk that's within the parentheses in this case is x plus 8. Junk squared, whenever you square something, for example, what's 3 squared? What's 4 squared? So when you square something, you multiply by itself, right? So if I say junk squared, that would be junk times junk. So whenever you have junk squared, that means you have to write it out twice. Okay? So in this case here, my x plus 8 quantity squared stands for x plus 8, x plus 8. Do you remember how you have to multiply that out? What was the acronym that you used for that? Starts with an F and then ends in an oil.
Oil.
Very good. Way to keep up. I know sound travels slower. FOIL. What does FOIL stand for? Remember?
Illinois.
Future of illiterate what? Leopards? I don't know. Thank you. Remember, this stands for first, outside, inside. Okay? When you're dealing with something like this, remember, generically it looks, since a lot of this stuff is going to be plus signs, I'm going to put a plus in the middle. As you this out last year because I know that all of you guys had to have an Algebra 1 class in order to pass to get to geometry. We hope. You did first. What's A times A? Well, he's here, so. Outside would have been A times B, so you just get plus AB. Inside, A times B, you get AB. And then last, B times B is B squared. Okay? Now, what happened then is that you guys would combine like terms. These two guys are the exact same thing. They have the same variables, so you just add their coefficients together. The coefficients for both of them are 1, so this is tough. 1 plus 1. You know, if you weren't staring at your phone all as much, you'd probably get better at addition. I know, call me crazy, I might know what I'm talking about, but it's going to be 2. So you get A squared plus 2AB plus B squared. Now, in our example here, if you FOILed this out, you have x squared plus 8x plus 8x plus 64. Okay? Yeah, it's Billy if I don't get it. Combine your like terms and you would rewrite it, you'd get x squared plus 16x plus 64. Notice how it followed the pattern. First term squared, x squared. Last term squared, 8 squared is 64. The middle term was 8 times x doubled. That's where I got the 16x. Okay? If you remember the special pattern, great. If not, can you just FOIL everything out and combine like terms? Yeah. Absolutely. Okay? Now, that's just one side of the equation. We got to go back to the other side. Here I have x squared plus 12 squared, so that's x squared plus 144. Are we okay with that? We'll just bring it down here. So I have x squared plus 144. Now I have an equation with variables on both sides, and I have different degrees of those variables. When you have different degrees on both sides, you start with, guess what degree meant? I'm saying that, I'm forgetting to ask you that. Degree is the exponent. What's the highest exponent you see here? Yeah, 2, so x squared. Notice, x squared on the right, x squared on the left. Isn't that the same coefficient? If I move the x squared over to the left, or excuse me, to the right, it cancels out. So what happens is you get x squareds on both sides that just drop. And all you're left with is a 2-step equation that every single one of you guys has done multiple times. 144 is 16x plus 64. Okay. Subtract the 64. We're left with 80, 16x, and I believe you get 5 for x. The idea here is that you're still using a geometry concept, but you're falling back to your algebra skills that you've done in years past. Okay? It's just starting to combine more and more parts. That's what the second half of geometry, or from here on out, that's what this class does with a lot of the algebra stuff that you've done. You're going to be reusing a ton of this type of stuff throughout the rest of the school year, really. Okay. Let's try another one like that. Same basic idea. Oops, that X is terrible. Okay. Same basic idea. Excuse me. I have 63x, and what's my hypotenuse if I wrote that out? It's going to be 49 plus x. What can you write as x plus 49? Does it matter? Normally, people would write it in variables first because that's more math etiquette to put it as x plus 49. So, which one of the, we just inadvertently stated what our hypotenuse was. Our hypotenuse was this guy here. Okay, it was this whole chunk. So this whole chunk is x plus 49. Okay? So when we start to write it out in terms of a Pythagorean theorem then, we'd have x squared plus 63 squared equals the quantity x plus 49 squared. Okay, so let's write this out. Now, really, the only difference between this one and the other one is the numbers are bigger, so you really need to use a calculator to multiply things out. Okay? So if you go through that, x squared, I just got to rewrite it. That's easy. 63 squared is something. I know it ends in a 9, but I don't know the other parts. What is it? 3969. Thank you. And now the other one, remember, it's junk squared. Write it out. Write it out, and then FOIL it out. Okay? Because if you don't do it that way, you're going to eliminate the x, you're not going to be able to solve it. First, x squared, outside, 49x. Inside, 49x. And once again, it's going to be some number that I don't know, but it ends in a 1.
2401.
2401, thank you. So now all that's left for me to do is combine like terms, and I get x squared plus the 3969 is x squared 98 and a 2401. Variables on both sides of the equation, they both have to be x squared. What happens to them? They cancel out. When you cancel them out, you say sayonara, sucker. Hasta luego. Hasta la vista, baby. Did he say hasta la vista, baby, in the movie? Or did he say hasta la vista? Did he say it with the baby?
He didn't say it with the baby.
Okay. Terminator.
It's been so long since I've seen that.
It has. It's... Yeah. Yes. It was like, he said, yeah, something like sucker. See you later, sucker, or sayonara. Was it sayonara, sucker? Is that where I got that from? I don't know. There was only something I could look up and find things whenever I wanted to.
Whoa.
So now, two-step equation, what do you do first? Subtract 2401. So we have an 8, 6, 5, 1. And if I'm not mistaken, we did this last hour. I think this is 16. Is that right? Well, think about it. That's really close to 1600, isn't it? That's really close to 100. Can't I just guess it's 16? Because isn't 16 times 100 1600? And also, don't I know that if I multiply a 16 times an 8, when I multiply 6 times, it's got to end in an 8? Just a guess. Okay. Not bad? Ish? I hope it's not bad, I should say. Do this one. For what? The other one? Huh. Ah. Solve that one real quick. This one they're just using R for the radius. If you want to change it from R to an X, that's fine. Go for it. All right, give that one a shot. We're gonna try one other. I got one other quick example to show you guys before we. Yeah. Well, last one's pretty easy to look at too. Yeah, think of the R as the X. It's just saying because obviously the R is the radius. So sometimes they'll use that. It doesn't matter what variable you use. It doesn't matter. It's not.
Show you that.
For the lack of time-wise here, let's see. So if you did this right, excuse me, if you did this right, you did x squared plus 15 squared equals the quantity x plus 9 squared. Okay? Next step, you would figure out what 15 squared is. You get 225. Here, you FOIL it out, x plus 9, and you should have gotten x squared, 18x, and an 81. Okay? What happens to the x squareds? Gone?
Robert. It is a joke.
Okay. Subtract the 81 over, and you wind up with, was that a 144? Is 18x divided out by 18. And what'd you get? 8? Sounds good to me. Not terrible, is it? It's just reminding you about how this stuff works. Okay? Last little bit is this thing called a common tangent. These are really easy to work with. A common external tangent. Common external tangent just means it's a tangent that originates from the same spot, outside the circle. The segments then, if they originate from the same spot, have to be congruent. Okay? So what happens here is if you look at the diagram that I threw in there, I have rays, AB and AC. The common point that they start at for both of them is at point A. Are we okay with that? They touch the circle at points B and point C, respectively. Since those two segments, the segment AB and the segment BC, originate from the same spot, point A, those two segments will in fact be congruent. Okay? Now, since it's tangent to a circle, what are those segments to the radii of the circle? Perpendicular. So what we can do is we can draw in a radius here, EC and EB. Then these guys happen to be perpendicular. And what do you know about all radii in a circle? They're also congruent. So I can double tick mark BE and CE. What shape does that then create? Kite.
Oh.
It creates the kite. Now, I can create a triangle here. If I draw the segment AE, what do you then have? We have what?
Triangle with the flexes.
We have two triangles. That are those? What do you know about those two triangles? They're congruent because they have side angle side, don't they? Okay. There's a little bit of that stuff that gets thrown in there. Now, the biggest thing with the tangent stuff here, if they're on the same spot here, if this is 22, what's that have to be? So if this is x minus 4, what would you do to solve for x? Sweat them equal? Yes, you'd sweat them equal, but you would also set them equal, and you'd get 26, okay? External tangents are ridiculously simple to work with. I didn't want to get too far with them. There's other stuff with tangents that obviously I'm running out of time to get into. We'll do more of that tomorrow. So what I have for you today is a handful of the types of kind of the Pythagorean theorem style problems that either have just straight numbers or with some of the variable stuff that we're doing with the jump square. So let's look at these. I want to get these in your hands first so I can show you a couple of the examples on here. Sir? then I owe you guys more. So if you look at that one real quick, take a look at number 4. Take a look at number 4 to start with real quick. Okay. So if you're looking at number 4, circle 10.5 is a what? The diameter, good. If that's the diameter, then your right angle has to be here, doesn't it? Because it touches the circle at one spot, whereas the other part, notice, it touches it at 2. So that's technically a secant segment. Okay, so it has 2 spots. So if it's trying to figure out, one of the things I want you guys to notice is that in these CUDA sheets, they draw a lot of brackets with arrows to show what parts are going where. You just have to read the question carefully to see what you're looking for. This one, they're just trying to figure out what's the entire hypotenuse, okay? You don't have to do any, x plus this or x plus that to get through it. You're solving for that chunk. This is straight Pythagorean theorem, okay? 10 squared, 10 and a half squared, take the square root, okay? Whereas if I look at number 6 directly below that, number 6, you have to be able to do a couple of things to make it work. So we have 8, 12, question mark. When I look at this diagram for number 6, it's only giving me one of the segments, or one of the legs of the triangle. 12 is what? What is that called? Very good. That's the thing. Sometimes you have to figure out what other information you can get from the given. We know that 12 is the radius, which means 12 is here as well. Now, where's my right angle have to go? What's your hypotenuse have to equal? 20. Okay. So because you have to do the 8 plus 12 for the whole section. Okay. There's a couple of them that are like that. We have to do a little twist with the radius. Then if you flip over to the back, you'll notice I was at numbers 12, 13, and 14 are all very similar to the foiling out ones that we did. Okay. So I would write down. Make sure you write down junk squared is junk times junk. Then the other 3, 11, 15, and 16. Those are your common external tangents. So what do you know about 1 plus 4x and 5x minus 11? If I'm looking at number 11. Those 2 segments have to be what? Equal. This should be relatively straightforward with a lot of it. If you start getting really, 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 really weird numbers, you done goofed somewhere. Okay? Yeah, it shouldn't be that bad. Okay? Get through these. We'll finish up. There's a little bit left in 12.1 to go through for tomorrow. And then I think tomorrow might be a little bit lighter because there's not that much. I don't need to get into the next section. We'll do that for Friday then. All right? Yes. What's that? Yes, ma'am. This 12 plus 8 is? It's convenient how math works sometimes.